Hi everyone, my name is Professor James Cheshire, and I'm going to talk to you today about how maps have been used in the past under very similar circumstances that we've been grappling with at the moment in the era of a pandemic that was killing hundreds and thousands of people around the world, and that people didn't really understand what was happening and where it was coming from and how to control it. So I'm going to talk us through how maps were used initially to send people off on the wrong track, and then one particular map maker, how they came in and actually helped to solve the mystery about what was going on. And then I'm going to bring things up to date and just talk very briefly about some of the work that we've done quite recently, looking at the outbreak of the COVID-19 pandemic in the UK and how that's affecting population movements and things like that. So hopefully you'll find this talk interesting, and it's kind of based on some of the work that we've been doing in terms of the research at UCL, but also the sorts of things that we might teach you if you come here in the coming autumn. And hopefully I look forward to teaching you mainly in actually the second and third years of your course. So I'll just switch over to the slides, and I've called the talk "The Power of Maps" just because we use this phrase quite a lot, and it's kind of a way of just really demonstrating how important maps are for solving real-world problems, and how we see them today as really integral tools to the way that we can visualize but also understand the world. So for the purpose of this talk, I want to take us back to London in around the 1840s and 50s. So over 150 years ago, London was being really impacted by a cholera outbreak. And at the time, it was killing many people, and there was a lot of effort to try and work out where it had come from, this particular disease, and to understand how it was kind of spreading through the population. And so just as we've seen today, or we see today, or the maps around COVID-19 and the various dashboards and things like that people have produced that have shown the spread of the virus initially from China, but how it came to our shores, people in the Victorian era were making very similar maps themselves. And so this was a map that was created for an organisation called the General Board of Health, who had people around the world who were tracking the outbreaks of new diseases. And in small red numbers here on the map, they've shown how cholera, in this case, started in India and spread westwards towards England and the British Isles. And this obviously was causing a lot of concern, because the outbreak was spreading through cities at the time. So this is a map from 1849 that shows the spread of cholera during the epidemic, and the grey areas, the ones that have kind of been shaded in, are the ones that had the highest numbers of cases. And you can see here that, broadly speaking, we're looking at a urban geography of the UK. So the city areas were the ones that were most hit. So we have London here, Southampton, Portsmouth, some of the kind of port cities like Liverpool, all were experiencing outbreaks of cholera. And at a time of urbanisation, where people were trying to move into cities, and the conditions there were not very healthy in many ways. There wasn't enough sanitation and very high density living and so on and so forth. Certain populations were definitely being more affected than others by the disease. And you may think, already that there are parallels between what's happening today and what happened back in 1849. And London was particularly badly hit through these successive waves of outbreaks of cholera, and lots of mapping was going on at the time to see where areas were most affected and where areas were least affected. And straight away you can see from this map of London, so here we have the River Thames, UCL, if you're interested, is located up here. We've got East London and West London, parts of Hyde Park, and so on. These areas, so West London, actually got off pretty lightly compared to, say, southern districts of the city, and also a central area called Soho, which we'll revisit in a second. So this is a scary time for London, and people wanted answers to what was going on. And the prevailing theory about the spread of disease was, or this particular disease, was the idea that it was spread by this thing called miasma, basically a bad smell. So if you could smell, in this case in London, London was a pretty smelly place, there were open sewers and so on. If you experience these bad smells, then that could be the means by which you contracted the disease. And so map makers at the time were showing how in this case, this is entitled showing the cholera mist of 1848 to 1849. So there's a lot of effort that went into map making, and this is a particular parish, small area of East London. So the city of London is actually here, and then this area here is known as Bethnal Green. And it's not really showing a huge amount, this map actually. It's just a shading in brown that's meant to show the mist as it spread over the areas and the places that were most affected by cholera at the time. And so people started thinking about this miasma, about this mist, and concluded that the weather or temperature played a big role in this. And it made sense in many ways, because the deaths from cholera actually increased over the summer months. So here we have July, August, September and October. And so warmest months of the year. These red lines here are showing some of the other kind of weather conditions, but crucially in yellow we have people that have died as a result of diarrhea, and then in blue we're showing the peak of people who are dying as a result of cholera. And so it's a pretty convincing graphic in many ways, because you can see how it kind of makes sense that you get this summertime peak, which is when London is the smelliest, and so this idea that the mist is spreading throughout the city. And so lots of people kind of subscribed to this theory and started endorsing it. In particular, there was one character called William Farr, who actually has an institute named after him at UCL. The UCL has a Farr Institute. And he was the kind of father of modern day population statistics. And he did a huge amount of work in carefully collecting data about populations. And so he was working in the 1840s at the time of this cholera outbreak. And he was very much kind of a strong advocate for this miasma theory. And he did some really intricate and interesting maps and graphics to support his view that it was in fact an airborne disease. And so these are each year we go from 1840 on the top left down to 1850 on the bottom right, and we have deaths of cholera, which are kind of these grey outer segments of the circles, and then we have climatic information and things like that on the inner circles and around the kind of the clock face. And so in this particular big outbreak here, these are the summer months we're looking at. So this is the same kind of data that I showed you on the previous graph. And so it was really him making maps and graphics to kind of prove his point in a very convincing way. At the same time, there was a physician called John Snow who was walking the streets of London, particularly in the area of Soho, which was that kind of dark area in the centre of the blue map I showed you. And you can see his approach was very different. So actually he didn't do particularly elaborate data graphics, but he did a very meticulous study of a small area of the city where he basically knocked on doors and asked the question whether anyone had died from cholera. And if they had died, they that particular building received a kind of a little black bar on it to note the deaths. And I think what's so extraordinary about this map is that the number of deaths that are occurring in particular buildings is very high. So this is something like 15 or 20 people that have died in one single building within Broad Street, which is the street we see here. But Snow had a different theory, and he was collecting data to try and support that. And his theory was that actually cholera is waterborne. So rather than receive the disease through the air, it's actually what you drink that was giving you the disease. And so he went round Soho, marking the locations of different water pumps and then counting who had died from the disease. And he made this very simple observation that the peak of deaths, where most people were dying from cholera, were adjacent to one particular pump. And he was then able to take samples of water from that pump. He got it sealed off, which then stopped the outbreak from spreading in any further in that particular part of Soho. And then he was then able to examine the water and determine that in fact it was within the water, the cholera existed within the water, because that particular well, that particular pump was being contaminated by sewage that was leaking into it, and that's why people in that area were particularly hard hit. So it's a simple graphic, or a simple map in this case, but it just shows the power of adding location to trying to solve the problem. So in the previous work that I showed you of Farr, he was just looking at the city scale. He wasn't really zooming in on what was happening at the street by street level. And that's really what the power of kind of Snow's work and some of the stuff that we're interested here in the research that we do at UCL is we are looking at very fine scale, very granular is the phrase we use, data about populations to see if it can tell us stories that are as powerful as the ones that we've seen in this graphic from John Snow. And this work, along with, he wasn't the only one that was pushing this theory, and but the theory was sufficiently strong to overcome what people were saying was the miasma, and so it became an issue of waterborne disease. And then it meant people were able to then enact change. So you'll see on this left-hand side here, this is the map I showed you just earlier on, where you had the cases in 1849. People then were able to take that death data from cholera and overlay it on a map that showed which company supplied water to which parts of London. And you can see here that the company in red, in this case called the Lambeth Company, they covered some of this area here and to the south. You can see straight away that there are certain patterns of people who are affected by cholera, maybe lined up with some of what the Lambeth Company was supplying, but also some of the Southwark and Vauxhall Company, which is the kind of greeny blue colour. So it's a fascinating case where these companies started to be held accountable for their actions, and perhaps knowingly were giving people water that they knew was contaminated in some way. And so we fast forward to today, and we can start to think about how we use spatial data and geographic data to plot and to inform interventions about what's happening in the current coronavirus outbreak. So here's a map I did a few weeks ago, which is probably one of the saddest maps I've ever made. It shows the deaths that at the time had been attributed to COVID-19. So this takes us up to the 17th of April. And on this map, I've mapped each death with a single dot. It's actually something similar to what I was trying to kind of, it's inspired a bit by what John Snow was doing by representing each death as a single point on the map, rather than these statistics that show big groups of clusters of people. And similar to the map I showed you before of the England and Wales affected by cholera, we can see that again the cities here where people live, or most people live, are the ones that are getting hardest hit by these outbreaks. And what's more, we can actually start to look at who is most affected and start to think about why. And so this is a graph that the Office for National Statistics recently released that shows the age, is called the age standardized mortality rates of death. So basically the chance of dying from COVID-19 based on the job that you do. And so you can see here that people who are managers, directors, senior officials, and kind of highly paid roles and so on, professional occupations, generally people that can work from home and self-isolate, they're the people who have the lowest chance of death. And then people that work in more lower skilled roles or in the caring sector and so on, who actually have to go out to work, they're the ones that are getting disproportionately affected by this outbreak. And that kind of follows, but it does mean that we can start interrogating what we might do to try and prevent some of these deaths. And so this is some work that we did with the Financial Times that came out recently, where we were looking at data from mobile phone apps. So rather than doing what Jon Snow did and knocking on doors, we were actually able to extract activity data, it's called. So we can get a rough idea of where people are and how many are moving around in different parts of the city. And we can start to see how much lockdown there was in a particular area. So whether activity levels massively dropped. And so in those areas, we would expect, obviously, more compliance with the lockdown. And then in some areas, you can see where there was less compliance. And it generally works out that areas that have higher numbers of the kinds of jobs we were talking about before, jobs that people have to go to work for, they're still seeing higher levels of activity than the areas like central London that are predominantly professional or financial jobs. And we can also start to see what people's appetite for lockdown is. And in fact, the work that we've done showed that towards the end of April, people started becoming more active. Activity started increasing around the cities, even though the lockdown guidance hadn't changed very much. So hopefully that is a nice overview of some of the work that we've done recently related to the COVID-19 pandemic, but also kind of a more historical view of where we've come from, where maps and data have become an essential part, or why maps and data perhaps have become an essential part of decision making and of understanding the complexities of some of these really important phenomena that are happening. So in this case, we're looking at epidemiology and social conditions and how those two maybe interlink alongside the geographical component, and why knowing where people are is such an important thing if we're going to make important and impactful decisions. But also I think it kind of gives you a bit of an insight, I hope, into the power and the value of a kind of a geographer's perspective on these things. And I do hope that over the next few weeks, as you're stuck at home, start looking around at these kinds of newspaper articles and some of the reports that are coming out and some of the stuff that the Office for National Statistics are doing, and start coming up with your own thoughts about why things are the way they are, and perhaps how we might inform interventions to change things for the better as the pandemic progresses, but also for any future pandemics as they occur.